What's up YouTube? Welcome to my channel. I'm Grutoski. I'm a graduating senior here at Elizabethtown College. I'm studying in computer science and data science, and this video will be going over my entire senior project for the year. And throughout the video there's going to be several timestamps. We're pretty much going to be going over the presentation, the poster, and we'll have a demo session at the end. So feel free to skip around in the video if you'd like and check out the project.
For this session in particular, we have two programs presenting their research work. We have folks from data science and also from mathematics. So as a first presentation, I would like to give you a few rules, unofficial rules. Rule number one, when the presenter presents, clap your hands as hard as you can. Rule number two, don't give hard questions. Yes, you can. You're welcome to ask any questions. We have 15 minutes for the presentation and 5 minutes for the Q&A session. So you're welcome to ask any questions to the presenter. Okay. All right. So for the first presentation, we have Matthew Grutoski presenting his work, natural language processing in the Metaverse. You can take it over. All right.
All right, welcome everybody. It's great to see such a great audience out here today. And as Dr. Lee said, my presentation is on natural language processing in the Metaverse. So we'll get things started. So a little bit of an overview of what we'll be discussing here today. We'll go into the background, discuss some paradigms. So what is the Metaverse and what is natural language processing? Then we'll head into some use cases and discuss how this can be applied in real-world scenarios. We'll discuss the models that were implemented for the project and how exactly that relates to natural language processing. Then we'll discuss the application implemented for the project. And then we'll go into a VR demonstration and check out the application design. And after that, we'll wrap up with some questions and Q&A from the audience. So first off, what is the Metaverse and a brief history? So we start off here with Web 1.0, which was designed in the 1900s. Features basic home pages, the read-only web, and the initial infrastructure that was laid out. And then hopping over to Web 2.0, features interactive advertisements, cloud computing, centralized data such as Facebook and Amazon, to give some examples, and then Wikipedia pages and blog sites. And then hopping over to Web 3.0 is where we are getting started with today. This boasts edge computing, the Internet of Things, so you can think of that as anything from garage door openers to smart home devices and like an Alexa. And then it also has blockchain technology for the decentralization of data. Things like NFTs are in there, and also artificial intelligence, and lastly, Metaverse applications. So what is the Metaverse and how can it be used in today's society? So the Metaverse is contained of a lot of different things. So some of those for headsets and hardware, we have virtual reality and augmented reality. So these are headsets that users can put on their heads and be transported into virtual worlds or have holograms appear right before their eyes. So these can transport users to social online worlds such as games or the newest and latest social media platforms that are coming out now. And also it can be applied to cryptocurrency and NFTs. A lot of the times in these new Metaverse games, you'll see like digital art galleries with NFTs and purchasable assets with cryptocurrency, and much, much more. So getting into what is natural language processing. Natural language processing is essentially just giving computers the ability to both understand natural and programmatic languages. So just like to name a few: English, Spanish, Python, and Java. So English and Spanish obviously being the natural languages, and Python and Java being the programmatic languages. So that's pretty much what natural language processing encompasses. And then going into some use cases, we have VR games and applications, chatbots. This could also be applied to various things like college tour guides, automating technical support via phone systems, financial consultants, math solvers, and the list goes on and on. And now hopping into the implemented models for the project. The first one is titled LDA. And this is a topic modeling technique used to group a group of documents or sentences together, and it's pretty much a classification model. So this is like a little diagram of what the LDA is doing in the back end. So you have a input data set, and you can picture this as just an example like CNN. They focus on a variety of different news topics. So it could be like financial news, real world news in the cities, and then these would be inputted into the model, and the output of that is just like a list of categories. So this could be like just an integer value from like 1 to 10, for example, and this would be categorizing the sentences as they're inputted into the model. And we use this categorization to give sentence responses to the user after it gets the classification. And hopping into the Siamese neural network, titled the SNN. This is a very similar approach to LDA, except it has deep learning techniques applied to it to boost the classification accuracy. And here is a diagram of how that was implemented in the project. So it's called the Siamese neural network because it has two of the same layers for the neural network processing engine. And so two sentences are fed in, similar to the LDA, and at the very end, it outputs either a 0 or a 1, depending on how similar both of the sentences are. So you could picture similar to the CNN example where there's like 10 topics that go in, and these would be, so sentence 2 would be your topic sentence, sentence 1 would be user input, and based on how similar they are, it will output from a 0 to a 1, and then we just simply get the top result from that to give a sentence result back to the user. And now we'll be moving on to more transformative natural language processing models. So this is Gpd3. It's an open source transformative model for natural language processing. And this allows you to take full control over how the model is trained and run after it has been developed. So it offers a decent pre-trained natural language processing with easy integration. It's 100% free for developers to take full advantage of. And this will actually output full customized sentences to the users after they speak into the model. And very similarly here on the next slide is the Gpd3 model. This is another transformative model, which is actually consisting of 175 billion parameters that it's been trained on, when compared to the Gpd3 model that is only trained on 2.7 billion parameters. So you could picture this as worlds above anything that Gpd3 would be able to give out in terms of sentences. This allows for more true natural language processing. So speaking into the Gpd3 model is much more intuitive. This is the most advanced natural language processing model that's available to the public, and you can fine-tune the training and apply Q&A techniques. So within the project itself, I actually utilize this to answer questions about the college and give specific responses based on what the user asks to it. And it just has one small caveat of having small monetary operation costs, but the operation cost is not that high for the amount of performance that you get from this model. And going over to the application and design, this is just a quick overview of pretty much the entire project here. So at the top is the Metaverse game that was developed in Unity, and it has a city environment, a AI non-playable character that you can speak to, along with a VR interaction controller to be able to control the headset and movements. And it has the various statistical models that are fed into the bot speech output. So users will speak into the model, and then a result will be given back to the user in real time. And this is just an overview kind of how the data is all transferred behind the scenes. So the Unity engine on the right-hand side is the client side of things. And when a user talks to the bot, the data is sent in the back end to a Amazon cloud server, where the text is then inferenced by these models, and then the server sends back the inference text to the user, where they can see that result in real time. So now we'll be hopping into the VR demo portion. I'm sure everybody is very excited to see the progress with that. So I'll just set this up here real quick. Create up our Guardian. And then we can get the stream going here. All right. So I'll stand to the side a little bit, just so you can see. And is everything good with the image? You all can see it?
Yes.
No.
Yes.
All right. All right, so now we're in the game world, and we can see the Metaverse Game World Showcase. We have a city environment here, and this is our little mock library here that we'll walk up to. So we have some metal doors to go through. And here's our AI bot. So we see this is just loaded up with the Siamese neural network to get things started here. So we could just ask it a sample question. How many students attend Elizabethtown College? And the model outputs to check out student life at this link. So that link will give you more information on exactly how many students attend. And swapping over the model here to our Gpd3. This one is trained on a variety of things, so more generalized than just speaking about Elizabethtown College. So we'll say, where is Elizabethtown College located? So we can see Elizabethtown College is located in Elizabethtown, PA, and that is correct. And now swapping over to the Gpd3 model that's been specifically trained on E-Town statistics. What is the best building at Elizabethtown College? So it says the best building at E-Town is the library, and that is in fact correct for studying. And how many students attend Elizabethtown College? Oh, there we go. E-Town has 1,688 students attending, and that is also correct. So that was a brief demonstration in the actual program. And there will be a demo session available later today at the poster session. So definitely feel free to attend there if you're interested in trying it out for yourself and asking questions to the bot. But now we'll move on to some Q&A from the audience. So does anybody have any questions?
Oh, how long did it take you make this program?
I've been working on it for roughly 6 months, and pretty much all that time has been utilized to its fullest potential on the project. Sure.
How much of the current VR space is run through Unity? And if there's other programs and engine bases, this be transferred over to it easily, or would it be something that would take some work?
Yeah, that's a great question. So a lot of the VR space, especially games, are developed for Unity. And so that being said, this project is all open source, and also contains like all of the Unity files coded in C# on the GitHub account. So anybody could feel free to access the GitHub, clone or fork it for themselves and modify it easily and utilize it. Sure.
Our college's motto is educate for service. Do you think that this VR program could be used possibly in the future as a resource for incoming students and current students?
Yeah, definitely. It could be, and that's a great use case for it actually, is students could in fact connect to it and utilize that Gpd3 Town model especially to get like real results. And that model actually inputs a Word document, so that could be easily modified by like school officials to include like new information about the college. And then students could just ask it questions similar to what the people would put in there, and it would give them real results. Yep.
Excuse as a homework helper.
It could be, yeah.
Okay.
The Gpd3 model can actually solve math problems or code assignments for you and give you give you all the code.
Proofs or something like that. Couldn't figure out where you did it wrong.
Yeah.
Could step in and maybe help you and point you towards the right direction.
Right, yeah, you're not wrong. I took proofs, so I mean it could definitely come in handy for that class, yes. Sure.
So how easy would it be to make the bot look like Conrad the Blue Jay?
Conrad the Blue Jay, it would just be a matter of modeling it up in Blender and just importing it into the game to change how it looks. All right. Well, if that's all the questions.
All right, thanks for our math presentation, and you did a great job. And I think everyone enjoyed the interactive bot thing in the Metaverse Matt was creating. So coming next, also Matt, do you want to advertise your poster session one more time?
Yeah.
Where's the
so,
location? What's the time?
Yep, at 3:05 there will be a poster session in the Bauer Center, and I'll be located most likely in the corner of the room so that the bot can pick up the most accurate voice signal from the users. But feel free, if you just want to try it out and interact with the bots, I'll have like bot grading sheets so you can actually like assess the model's performance and ask it questions about the college or any like math questions or anything. So feel free to stop by for that. That'll be a great time. All right, and now we're just gonna do a brief little overview of the poster for the project. Feel free at any time if you'd like to pause and read more details on each section, but I'll just be going over each of them in brief detail. So for the opportunity of the project, there's a very clear disconnect between the way that users in VR interact with different applications and games. So this project is really just to merge those lines of reality and being able to talk with interactive chatbots and obtain more realistic examples from when they talk to the bot. So for the design specifications, I created a VR game to showcase the different bots that were implemented on the backend server. So here's like a little diagram of what is all implemented as far as the game and the different statistical models that I utilized on Python. And for the technical design, I used a TCP network protocol to implement a client to server connection and pass the text data back and forth. So the general idea is the user will speak into their headset, it'll be converted to text, sent over the TCP protocol to a Python server. And on the Python server, it will be analyzed by a statistical artificial intelligence model, and then that text result will be sent back and spoken back to the user. So that is it for the TCP data pipeline. And then for the different models that were implemented, there were several clustering models that I utilized. So these include the Siamese neural network, T-distributed stochastic neighbor embedding, which is just TSNE for short. That was used for getting the EDA results. So this is a model of the TSNE clusters that were obtained from that. And lastly, I utilized the LDA for clustering classification of the sentences. And for the transformer models, I majorly utilized the Gpd3 model and GPD-Neo and trained those specifically on Elizabethtown College statistics and different facts from the college to obtain specific domain knowledge on all of those facts. And then moving over to the prototype and the devices that were used. So I used a MetaQuest 2 headset for completely wireless capabilities. So this allows the user to not have to set up any cameras or fuss with any wires connected to the headset. It's just purely all wireless. The whole game runs on the headset. It's all exported in Android and run on the Quest natively. And the control scheme for the game is shown here. And for testing, models were evaluated on a variety of factors. So one was just the question that was asked to the bot. And the second factor is the result received from that bot. And then participants who participated in the demo session were asked to grade the bots, and those results were all logged and will be in the paper. And here's just a flashy impact section here about what natural language processing will do in the coming years. So it's set to be the status quo in many industries, from technical support to chatbots, etc. And lastly, just ending off, we have references and acknowledgements. And then again, feel free to pause and read over the poster to get a more detailed overview of what's all on here. Questions that you wanted to ask the bot. If you have any lottery numbers that you want, feel free to take notes on that. And yeah, just let the questions loose. I'll just go in and I'll ask it some questions.
Matt, what's the best bar in E-Town?
Best bar.
What is the best bar at E-Town?
Borat.
The best bar at? That's what I think I said. Here, we'll go to the Gpd3 Model. And we'll just ask it for the best bar in general. What is the best bar to grab drinks at? The most people. Yeah. The best bar. What is the best dance club? That's fire. That's a good answer. That's a great answer. Test?
I don't know.
Where is the best place on Earth? Somewhere in the United States.
Cool.
So keep an eye out. What is the best place to go on vacation?
Matt, ask him what the best wing flavor is.
The best what?
Wing flavor.
What is the best wing flavor? What is the best wing flavor?
Garlic.
Garlic Parmesan is really good.
That's a good one too. But it depends on where you get it from though.
That is true.
How's the Wi-Fi in Elizabethtown? Oh, it sucks.
No, I'm not gonna ask that. We're gonna skip over that one.
It's because we know it's terrible.
We know the answer to that.
We know the answer to that
Alright, so
Ask, are you part of Skynet?
are you part of Skynet? Do you know what Skynet is? It knows what it is, but it doesn't know how it works.
Smart.
Ask him what his IQ is.
What is your IQ?
I don't trust it. I don't trust robots.
All right, that about sums it up for this one, guys. I'd like to give a special thanks to Luke Moynihan for helping with some of the statistical models as well as dataset creation. And also special thanks to Dr. Lee and Elizabethtown College for supplying the Quest 2 necessary for testing purposes. And I hope you guys have a great day and check out my other videos.